Hi there, Math 30-1 student. I'm just going to explain this review concept in this web lesson, which covers mostly all the topics that deals with this lesson 3. So I'm going to just share my screen here and let's talk about the question on hand. So first off the back, you will realize what our goal is. P of x equals to x cubed minus 2x squared plus ax plus 6. When P of x is divided by x minus 2, the remainder is negative 4. List all the possible quantities of P of x. So this is talking about the degrees. This is also talking about other factors of constants, the integral zeros, and so forth. So right off the back, we know this is a degree of 3. Okay, so degree of 3. What else can we say right now? Well, we currently also know that it is a cubic function. Okay, and so that means it could have 3 solutions. Possible of 3 solutions. Possible 3 solutions. And this means that it has possible of 3 solutions. Why don't we actually write out this into a Desmos activity to see what it can actually be, the A value currently, to help us on here. But before we do that, you also should see that the constant should be, well, 6. So the y-intercept of this graph is going to be 0, 6. Okay, and then you will also realize the integral zeros for this problem. We'll have to look at the constant, which we just talked about. So that means our factors will either have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So those are all the possible factors that they could have for this one. Okay, the next bit we're going to look at is determine the value of A. Before we determine the value of A, I'm going to share my screen that deals with decimals, and you will realize we don't know what the A value is currently. We know that it will look like it goes from quadrant 3 to quadrant 1 regardless, and the end behavior for it. So this is going to help us. So if we have a more positive value for A, we look like a more of a straight line. So if we have more of a negative answer, now we have more zeros that are possible. As you can see, you could just click on there, there's your zeros. So let's go tackle what the value of A can be. To do this one, what you're going to be realizing what we need to do is, well, understand that we already know a value for this, meaning that when P is, what was it, negative 2, so that means we need to substitute 2 in here. It gives us a remainder of negative 4. So this is going to be negative 4 when we actually solve for that. So we're going to substitute 2 basically inside the whole equation here. Okay, so I'm going to go substitute 2 in there. So 2 cubed minus 2, square that, plus ax plus 6. Okay, so what we need to do now is this p2 equals to negative 4 because that's the remainder, what it equals to. This is 8. This is 8 because 2 squared is 4 times 2, 8. And then we have ax plus 6. Oh, hang on a sec. We could substitute x to be what we said right over here, which is 2. Okay, so what do we have now? Negative 4 equals to, this is 0, plus 2a plus 6. Minus 6, minus 6. What do we get now? Well, we're going to get basically negative 10 equals to 2a divided by 2, divide by 2, and a will equal to negative 5. Okay, so that means if we go back to our graph, let's just share this and go back to decimals. We need to make a equal to -5. Okay, this means these are our zeros, a -2, 1, and 3. That means those are 3 factors we're going to be doing to part C when we need to factor it. So this is the nice thing, actually changing this to now to -5 should look like the following, as we just said. So those are the 3 factors we're going to be dealing with. And let me just go back to my screen that I was working on. So C was dealing what is the factored form. Well, it's going to be x equals to -3, comma, -1, comma, and +2. Okay, so once again, how did I get these? I needed to take them from the graph. Now, I need to put those in factored form. So P of x equals to x cubed minus 2 x squared minus 5x plus 6. Okay, now you can rewrite that in factored form. X plus 3, x plus 1, and then x minus 2. Those are your factors that's going to happen here. Now the next business in the question that pops up in the end, we want rewrite in factor form. We did that already. Change one of the factors to a multiplicity of 2, another factor a multiplicity of 3. So if this could be, you could get many answers for this one. So they want us to use this right here, change it to a multiplicity of 2. So if I took x plus 3 and changed it to a multiplicity of 2 or 3, so let's change it to 3, that means I need to do another one as multiplicity of 2. So this just means it repeats itself on the actual graph when it touches the x-axis twice. And the same thing would happen here. So this would be x minus 1. That's basically what that would look like. You can have many answers here, by the way. So what's going to happen here now is, well, I'm going to write that in decimals and see what it actually looks like. Now, keep in mind, I can tell you right off the back, it's a degree of 3 plus 2 plus 1. So that gives us a degree of 6 in even and out. So let me just stop sharing on this screen and go back to the other one. Okay, so I'm going to change my equation here. I'll leave the other one there. It doesn't hurt. Y equals x plus 3 to the exponent of 3. Okay, x plus 1, the exponent of 2. And then the last one would be x minus 1. Okay, so that means the purple one is what it looks like. You will realize these are the factors that is occurring. And I just need to basically, oh, I see what the problem was. It should be x minus 2. Okay, so the reason why I'm saying that, because those are the values that I got earlier. And x plus 3. Okay, hang on 1 sec here. When I graph that, my solutions for the red one was minus 2. So that should be x plus 2. Okay, I see what happened here. So I'm going to go back to here and share the screen. Okay, so I need to change this to x plus 2 because this should be the inverse of it when you write it as a factor. This should be x minus 1. Okay, so I'm going to rub that off. It should be x minus 1. And the other one should be x plus 3, so it's x minus 3. Why is that? There they are. So those are the inverse of that. So I'm going to rub this one off. This should be x minus 3. And there we go. Minus, minus, and the other one is a 2. There we go. So now I'm going to go back to Desmos and actually graph that and what it looks like. Okay. The reason why I'm doing that is to making sure that we have the same x-intercepts that occurred. So let's go back to here. This should be x minus 3. This should be x minus 1. And the last one should be x plus 2. Okay, as now you can see, they cross at the same places. Multiplicity, you will realize it curves right at the x-axis and breaks them back down to the same quadrant. That determines the multiplicity of the amount of times it occurs. Okay, so in a nutshell, this is what the question was asking. Hopefully that helps. Have a great day.